So good morning, guys. This is the statistics class 1401. We are going to work on 3.4. Just let me make sure I'm not. Yes, it's 3.4. I did upload some of the assignments from 3.4. By the time we're done with our section, you should be able to do the problems from 3.4. I don't think this is a hard section. It's a new topic, and the ideas are not that difficult. All right, guys? At least that's what I think. Let's start. The first thing we study is called the z-score. What is z-score and why do we care? Okay, when you have two sets of data, okay, from last year and this year, and you're comparing two candidates, one candidate from this year, one candidate from last year, you want to see how far above they are, how far above the mean they are in terms of the standard deviation. If they're one standard deviation above, two standard deviation above, one standard deviation below, all those things. So z-scores help you compare two different data sets, individual data points from two different data sets. And it really doesn't matter. The sample and population z-score formulas are really the same. The score, z-score, the score you're finding the z-score of minus the mean divided by the standard deviation. Now, in most of these problems, either the mean, both the mean and the standard deviation will be given to you. Okay, so I picked a problem from your MATLAB and I would like to do that. So let's try it. There is a very nice problem in your book. Feel free to check it out. Let me share with you the problem. This one, okay, it's the work is all done here. Okay, look at it, check it out. It's very nice, nicely done. But I'm going to do something from scratch. So I'm going to take this. I'll try to do it carefully. So this is my question. Now I'm going to save it here, a small version. I don't need it really. The mean finish time of a yearly amateur auto race is 187.18 minutes with a standard deviation of 0.361. Okay. The winning car, driven by Ron, finished at this point. The previous year's race had a different mean, of course, 110.4, standard deviation of 0.38. And the winning car that year was Betty. So I'm going to find Betty's Z score compared to the data set from the last year and Ron's Z score. I'm just going to write N subscript Z for Ron's Z score. And what is it? His score, 187.18. Subtract the mean for the group. Okay. Actually, his score, Ron's score is 186.61. And you will divide it by the standard deviation, which is 0.361. I'll write it properly here. I'm kidding. My z score is negative 1.57. for Ron. That means Ron was um, about 1.57 standard deviations below the mean. Okay. Now I'm going to do the same thing for Betty. I do have the answer, so I'm going to check it actually. So it's very easy to mess up. I'm going to hide this. I need the room. Okay, Betty's z-score, you have to use Betty's average, which was, raise, the time was 11.4, the mean was 11.4, sorry, 110.4, and the standard deviation was 0.138, and Betty did 110.23. What do we get for Betty? Well, this I have to be careful and not make a mistake. So Betty's z-score is going to be 110, 110.23 minus 10.4 divided by the standard deviation, 138. I'm getting negative 1.23. So Betty was also below average, and so was Ron, but Betty was closer to the average because Betty was only 1.23 standard deviations below the average, and Ron was 1.578 standard deviations below the average. So I would say Betty did better than Ron. So this is how, using the z-score, you can compare independent data points from different data sets from different time. Okay? Try the problem in the book, and that's also nicely done. Take a look at it. I did one from your math lab. So moving on. Okay, this is a fairly easy concept. Hit percentile. Um, I can say the 30th percentile. What does it really mean? Of course, you can read it, okay? So if I can say 30th percentile of the data, 30th percentile simply means of the 30th percentile of the data was 50. That simply means 30% of the people got 50 or below. That's all it means. That's what's saying on top. 30th percentile of the data is, let's say, 80. 80, 30% of the people got below 80. That's all that means. All right, moving on. As I said, I don't think this is a hard section. There are lots of isolated ideas. All right, so we're going to find quartiles and IQR, and we will see how we do it. All right, guys, quartiles are let me define it nicely. Give me a sec. Let me start a new page. Okay, guys. So we're going to find quartiles. Q1 is called the first quartile. 25% of the data is going to be below Q1. Q2 is called the 50th quartile or quartile 2. 50% of the, not 50th quartile, well, it will be 50th quartile as well. 50% of the data will be below Q2. And Q3 is the third quartile, and 75% of the data will be below Q3. Let's write it down nicely, okay? It's something we're going to spend a little bit of time on, so you want to make sure you understand it. Okay? And how do we find these quartiles? I'm going to use a problem that your book uses. So how do we find, if I give you a data set, how do we find quartile 1, Q1, quartile 2, Q2, quartile 3, Q3? Now I do have a data set. This is a problem from your book. We're going to use the same data set, and I'm going to use Excel. Okay, this is the table, and I entered the data as correctly as possible. You can check. We're going to check our answers. So if my data set is wrong, I'll be wrong. So I'm going to make a quick check, okay? Uh, I got I got a data point here wrong. Glad I checked. 21. Okay, then 2332, 189, 1185, 370, 1414, 4668, 1953, 134, 37. All right, so I have here 18 data points. All right. First, you have to find quartile. So this is my original data point. I don't want to mess it up. I'm going to highlight it. Okay. First, when you find quartile, you have to um, write the data in ascending order. Most of the time we do ascending, arrange it from the lowest to the highest. And we did it. We did it. Now, if it is, I'm going to make it ordered. So I'm going to change the color to, let's say, blue. I'm more focused on the blue one, which is basically the same data set, but this time it's ordered to find Q2. If it is, and if you have an odd number of data points, the middle one, okay? If you have 5 data points, the third one will be your Q2. That's easy. If you have 11 data points, the sixth one is the middle one. That'll be your Q2. But here, I have 2 middle ones. I have 9. So I think these are the middle. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So these two are the middle data points. So to find Q1, I'm going to write Q1. I will add these two numbers, this number plus this number, and then I'm going to divide that answer by 2. And that's your quartile 2. Done. Now, sorry, this is quartile 2. Done. Now, for quartile 1, you're kind of going to do the same thing with upper half of the data. And for quartile 3, you're going to do the same thing with the lower half of the data. Now, the upper half of the data is going to be this data set. Okay, I don't need this. And let me go back. All right. So basically, how do we find the middle number? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this has to be the middle one. And this has to be the middle one. Okay, if there were 2 in the middle, you would be finding the average. So that's easy. So I'm going to give you a little summary of how to find Q1, Q2, Q3, and Q1, Q2, and Q3. For first, you have to order the data and find the middle data. If there is one data point that's in the middle, that's your Q2. If there are 2 in the middle, you will find the arithmetic mean of those 2 numbers. And for Q1, you're going to take all the top or the lowest half of the data points or the first half of the data points and find the median or Q2 of that data point, those data points again, you're going to get Q2, Q1, and Q3 is do the same thing with the other half or the higher half. Now that you have Q1, Q2, Q3, those are things we calculate to do a bunch of things, okay? We can find IQR. It's called interquartile range. And for that, we'll have to open a new page. We'll use it in a bunch of things. Okay. So basically, it's actually a measure of dispersion, just like um, standard deviation. So we basically IQR is Q3 minus Q1, and that tells you the variability in the middle 50% of the data, or the range of the middle 50% of the data. Sometimes we are only focused on the middle 50% of the data because most of the interesting things, or if you want to say boring, doesn't matter. Most people fall in that category, you and I, average people. So how do you find Q3 minus Q1? Well, I'm going to go back to my same example. All I have to do is find Q3, subtract Q1, and my Q3 right here is this guy, and my Q1 is this guy, and I have to subtract them. That's all I need to do. And I'm done. I'm done. That's my interquartile range, IQR, which is basically Q3 minus Q1. Moving on. And here's another example from your book. I wonder if it's the same one that I did. It's not a bad, yeah, it's the same one. We got the same answer. That's a good thing. All right, guys. Now, what are outliers? Okay. Outliers are examples of extreme data points, the ones that are really low or really high. To find the outliers, if to find if a data set has any kind of outliers, first you have to find IQR. Before you can actually find IQR, you have to find Q1 and Q3. So you're going to find the lower, it's called the lower fence. Remember how we find Q1 and how we find IQR? Q1 minus 1.5 times IQR is the lower fence, and Q3 plus 1.5 times IQR is the upper fence. If you find a data point above the upper fence, it's an outlier. If you find a data point that's below the lower fence, that's also an outlier. Got it? Now, we're going to use the same data set because we are building on it, right? We are doing the same problem. So let's say if this data set has any outlier, we found the IQR, it's right here, IQR, which is this, we have Q1. So Q1, so let me put that, this is the problem we're working on. I know you can't see the whole thing, but it doesn't matter. We are interested in the data set. And I'll bring it here just for, oh, anyway, it won't let me bring it, but I'll see. I'll try it once again. All right. So, guys, I want to find the lower fence. Well, how do I do that? Well, easy. Lower fence. It's Q1, which is this number. All right. Minus, I'm going to put minus, and I'm going to find the IQR, which I already did. It's above, right? I'm going to take the IQR and subtract it, multiply it by 1.5, and multiply the IQR by 1.5, and did it here. All right, so what do I get? Q1 minus 1.5 times IQR. And I get, this is 1.5 times K11. That sounds about right. And I'm going to say here, wow, I don't have negative data, so I don't have anything below the lower fence. Clearly I don't. What's the upper fence? Let's find the upper fence. Upper fence is the same thing, but this time we start with Q3, and we're going to put Q3 here, which is this number, and we're going to add 1.5 times IQR. And IQR is this, 3,933. So we're going to be adding it. And we're going to be adding this. plus this. Yep, we have an outlier here, this one. It's very expensive. So upper fence is 10,567. If anything is in your data set that's higher than that, that's an outlier. Now, of course, we won't have any negative numbers in this data set because of the way it's structured. Um, the lowest is zero. We don't have a lower fence. We don't have another outlier that's very low. We have an outlier that's very, again, outliers are exceptional cases. That's how we calculate outliers, by finding out if something is below the lower fence or something is above the upper fence. Okay, before we move on, guys, I have a student who asked me to do something. Let's see if I can find it. I'm going to go to my email, do the problem, and I'm doing the problem for her, for everyone, actually. Okay, right here. So this problem says which histogram depicts a higher standard deviation? Remember, guys, standard deviation is variability. Okay, I would say 70 is here and 30 is here. 70 minus 30 is going to be 40. And here, everything is between 60 and 40. So everything is kind of more compressed, relatively speaking. Everything is between 40 and 60. So I would say the one A has higher variability or has higher standard deviation. Things are spread out more in dataset A, and they are spread out less in dataset B. I hope that helps. And that's all the lesson I have for you today. I will see you next week. Have a good weekend. And if you have any questions you want me to help you with, please don't feel bad. Don't hesitate to ask me. Thank you and bye-bye.